In this video, it's going to be up to you to use the object property shorthand and destructuring, which we covered in the last video, inside of the weather application. Now to start, I'm going to take our destructuring and object property shorthand playground file, and I'll move that off to the right-hand side so we have all of our weather app scripts side by side over here. And from the terminal, I am going to switch back into the weather app directory since we'll be running that application in this lesson. So cd:/weather-app. Now, once we're here, the goal is to figure out what exactly we're supposed to do, and as always with challenges, I have a set of challenge comments describing what I'd like you to get done. The big picture goal is to use both destructuring and the property shorthand syntax inside of the weather application. First up, you're going to use destructuring in app.js, forecast.js, and geocode.js. All three of these have an instance where we're using properties from an object that we could just destructure instead. Down below, we grab things off of data. Those properties could be destructured into individual variables. In forecast.js and in geocode.js, the only thing we ever use off of the response object is body that could be destructured as well. From there, we can talk about using the property shorthand syntax. This can be used in forecast.js and in geocode.js. In both files, we set up the options object we pass to request, and we could use that syntax in there. So take some time to knock out all of those refactors in the files listed for each. Then when you're done, test your work. So make sure you can still run the application and get the expected weather output. All right, pause the video, knock that out, and when you're done, come back and click play. How'd that go? I'm going to kick things off with app.js. Now in here, we can use destructuring, but there is no use case for the object property shorthand syntax, and that's okay. Down below, geocode has its callback called with two arguments. The first is error, which is a string, and the second is data, and we know that data is an object. We use three properties from it: latitude, longitude, and location. We're going to go ahead and destructure those instead of accessing them off of data. Up above, we have data. I'm going to remove that, and we are going to destructure the second argument passed to the callback. Right here, we are going to grab three things from it. First up, we have latitude. Then we're going to have longitude. And finally, we're going to have location. This is Andrew from the future with a quick update. As a couple of students correctly pointed out, there is a small problem with the line of code that we just wrote, and you can see that line of code under existing code right up top. Now, the problem is something you'll only run into if you end up calling geocode and an error occurs. If you call geocode and you do indeed get back the latitude, longitude, and location, things will still work just fine. Now, this is a legitimate error, but it is something that I planned to cover later in the class. So all of the stuff we're going to talk about right here, it is covered in much more detail in the fourth lesson of section 8. Now, if you run into the problem between now and then, you might think your application is broken. So I'll take a quick moment to talk about the code change we'll end up making so you can put it in place right now. Then, in the fourth lesson of section 8, we'll end up talking about this in greater detail. Let's start by exploring the problem by talking about the existing code right up top. So if we call geocode and there's no error, things go well. We do get our object as the second argument to the callback. We destructure latitude, longitude, and location, and we will be able to use those in our function down below. The problem that we're going to talk about comes up if you call geocode and an error occurs. So if an error occurs, the callback is only called with that first argument, the error. No value is provided for the second argument, and we know that if we call a function and no value is provided for an argument, the default value is undefined. So long story short, if we call geocode and an error occurs, what we end up doing is trying to destructure off of undefined, which is going to throw an error. We can only destructure off of an object. So now that we've explored the problem, let's talk about the solution briefly. Let's get started by talking about the code at the very bottom. So at the very bottom, we are using the ES6 default function parameters syntax. This is the new feature of JavaScript we'll talk about in detail in Section 8, Lesson 4. But let's briefly touch on it here, just so we can understand the change we'll make to that one line of code. So down below, we set up a pretty standard function called greet. It takes in the user's name and it prints a message using console.log. So if the name was Mike, it would print hello, followed by Mike, followed by an exclamation mark. Now, what if we call greet with no name? In that case, we would get something like hello undefined. So what if we wanted to provide a good value for name if no name is provided when the function is called? We can do that using the default function parameters syntax. So I've added a red underline under the new code that uses this feature. So right there inside of parentheses, I call my first argument name, then I add space equals space, followed by the string user. So that is the new syntax. This says if we have a value for the first argument, go ahead and use that value. If we don't have a value for that first argument, go ahead and use the string user. So we can see this in action in our two function calls down below. When I call greet and I pass in Andrew, I see hello Andrew. When I call greet and I don't pass in any arguments, I see hello user, so it falls back to the default. Now you could run this code in your application to see this in action, and as mentioned, we'll cover this in way more detail later, but that's a quick idea of what we can do with the ES6 default function parameters. Now let's talk about how we'll end up changing that one line of code. So up top, we have our existing code that we just wrote. In the middle, we have the new code with a few characters added, and I've underlined those in red. So right there, we are using the default function parameters syntax to set up a default value for that second parameter. So if a value is provided, we'll use it. If no value is provided, the default of an empty object has been configured. So now let's explore the two scenarios when geocode runs successfully and when geocode fails. So if geocode runs successfully, we'll end up calling our callback with a value for the second argument. If we provide a value, then our default won't be used. So we'll destructure all of the data that we got back from the API, and we'll be able to use that in the function down below. That was never the problem. The problem is if we got an error. So if we call geocode and an error occurs, the callback is called with just the first argument. In that case, the second argument would not be provided, and our default of an empty object would be used. So from there, we would end up destructuring latitude, longitude, and location off of that empty object, and that's fine. That is perfectly valid. The value for all three will be undefined. So the program won't crash. We will just get undefined for those three values, which is fine, because we're never going to use them if the error exists. So that's the brief change we need to make. And once again, you might have been able to go through the class without ever running into this before I explained it, but a few students were. They were confused, and my goal is to create a class that's seamless, that works from beginning to end without problems. So right here, I just wanted to jump in with an with an explanation, and we'll go back and talk about all of this in more detail in the future. So sorry for that quite long transgression, but now that we can understand the change we need to make and what it does, let's add that change to our code, then we'll jump back in to the regular lesson. Now at this point, our program is broken because we're still using that data variable, but it no longer exists. We're going to remove data and dot in all three locations. Now we're just referencing latitude, which is indeed defined. We're just referencing longitude from up above, and down below, referencing location. Now that we have this in place, we can actually test our work before moving on to the other files. It's always a good idea to test your work as you refactor, so instead of getting to the end and having a bunch of different files that could have caused the error, it's easier to isolate the problem if you run the program multiple times. So node app.js, if this works with a search term like Philadelphia, then we know our refactoring here is good. If it doesn't work, we know that it must just be the changes we made to this particular file, making it easier to figure out what went wrong. Now let's move on to the other files. Forecast.js and geocode.js both which can use destructuring and that shorthand syntax. Over in forecast.js, we can use the shorthand syntax in the object we pass to request. Instead of referencing a URL variable to get the URL property, we can use the shorthand syntax, which does the exact same thing. This is still setting up a URL property whose value comes from the variable up above because the names are identical. Now we can also use a little bit of destructuring. Down below we have error and we have response. We know response is an object, but the only property we're ever using off of it is body, so we could just destructure that. I'll remove the response argument, set up my curly braces, and list out body right here. Down below, we can now remove any use cases of response, replacing them with just the call to body. So right here, instead of response.body.error, I have body.error, and I'll remove response dot down below. I have it 3 times as we generate the forecast, and I'll remove it in all 3. Now we are just referencing body, which does indeed exist as a standalone variable because we destructured it up above. Last up, we can move to geocode.js, which is very similar to the forecast file. I can use the shorthand syntax right here once again when setting up the URL, and once again I can destructure body off of response. Now there are 4 situations where we used response before. Once right here to fetch the length of the features array. That's going to be just body.features.length now, and down below we used it for each of these 3 property values. So I'm going to take all 3. I'm going to remove response dot, accessing just the body object. Now that we have this in place, we've done all the refactoring. That is steps 1 and 2, and we're going to move on to step 3 and actually test things out for a final time. So down below from the terminal, let's go ahead and rerun the program. Right here, what do I get? I get my forecast still printing. It is for the correct location, Philadelphia, Pennsylvania in the United States, and I have my forecast. Rain in the morning? Yep, it is indeed raining outside. It's currently a bit chilly with a 0% chance of rain as we continue through the day. Now that we have this in place, we are all done, and that is an introduction to ES6 destructuring and the object property shorthand. We're going to use both of these extensively throughout the class now that we know about them. Sure, there are other situations where we could have used these in notes.js, but we'll just continue to use these features going forward instead. Speaking of going forward, let's go ahead and jump right in to the next video.